Coordinate geometry is where CAT turns pictures into numbers. The whole idea is to stop treating a figure as something purely visual and start seeing it as a system of coordinates, distances, ratios, and slopes. Once that shift happens, many geometry questions become much cleaner because the diagram is no longer mysterious, it becomes measurable. That is the real advantage here. A well-placed point can tell you almost everything if you read it correctly. The logic of coordinate geometry is beautifully simple. A point on the grid gives you algebraic information, and that algebra immediately tells you geometric properties like distance, midpoint, ratio, and area. The big advantage is independence. X and Y can be handled separately, so a tough figure often breaks into two easier one-dimensional problems. That is why coordinate geometry feels so powerful in CAT. It converts a visual problem into a clean numerical structure. The reason this topic matters so much is that it saves time in high-pressure questions. A slow visual construction may look elegant, but the algebraic method often reaches the answer faster and with fewer mistakes. CAT loves combining geometry with algebra, so the student who is comfortable with coordinates usually has a clear edge. The key mindset is not to fight the coordinates, but to use them as a shortcut to expose the structure of the shape. The central formula here is the section formula, which gives the coordinates of a point dividing a segment in a given ratio. This is one of those tools that appears constantly because it connects points, ratios, and linear structure in a single step. A useful observation is that you only need one axis at a time because the x-coordinate and y-coordinate follow the same ratio logic separately. That makes the formula far easier to use than it looks at first glance. This challenge problem is a classic speed test. 3 points are given and the task is to find the ratio in which point P divides A, B. At first glance, it looks like a full calculation problem, but the figure already suggests that the point lies on the segment in a way that can be read through coordinates. This is exactly the kind of question where students lose time by overthinking, when the real answer is hidden in a direct ratio pattern. This is the long method, and you can already see the problem. Too many steps. You assume the ratio as lambda to 1, apply the section formula, substitute values like 2 minus 5, and then go through multiple algebraic steps just to finally get lambda equals 2.5, which gives the ratio 5 to 2. The issue is not that this method is wrong, it's that it's slow and error-prone. In exams, the more you write, the higher the chance of making a mistake. The goal is always to look for a cleaner, shorter path instead of getting stuck in heavy algebra. The toppers method is much faster because it reduces the problem to a one-dimensional jump on the number line. Instead of working with the full coordinate setup, you compare the vertical drops directly from 5 to minus 5 and from minus 5 to minus 9. That gives the ratio immediately as 10 to 4, which simplifies to 5 to 2. The big lesson is that in coordinate geometry, you do not always need the whole plane. Sometimes one axis is enough to crack the question in seconds. This is where the deeper geometry comes in. Collinear points enclose zero area. So if 3 points lie on a single straight line, the area test becomes immediate. The strategy is to equate slopes and skip unnecessary distance formulas. That is a smart move because many students waste time trying to prove what the slope has already told them. The important insight is to recognize that collinearity is just a flat triangle. No height, no area, no complexity. Area questions in coordinate geometry often look scary, but the shoelace method makes them much easier. The slow method relies on the standard triangle or polygon area formulas, while the fast method stacks coordinates and cross-multiplies them in sequence. This is especially powerful for any polygon area question because it avoids breaking the figure into smaller triangles. A good exam habit is to memorize the pattern once and use it repeatedly because the same structure saves a lot of time. The advanced area formula is just the same shoelace idea written in a compact operational form. You cross multiply it downward and upward, subtract the two totals, and take the absolute value to keep the area positive. The diagram makes the coordinate pairing very clear, which helps avoid mistakes while applying the pattern. The real advantage is speed. Once this method is fixed in memory, many polygon questions collapse almost instantly. The cheat sheet ties everything together in a compact revision block. Distance is just the Pythagorean theorem in coordinate form. Midpoint is the average of coordinates. Section ratios come from one-dimensional jumps, and centroid is the average of the three vertices. That is the core of coordinate geometry in one page. Observe the structure, convert it into coordinates, and let the formulas do the work. The final mindset is exactly right for CAT. Stop calculating blindly, start observing sharply, and the clock becomes much easier to beat.